Dear students, I am going to start about the base and the nucleophile. What is base and what is the nucleophile? We cannot distinguish because both terms are the interrelated. Base and the nucleophile or the interrelated term. A substance for one time acts as the base, but for the other time the same substance acts as the nucleophile. A substance when it donates an electron pair to proton, electron pair to proton, that is H plus, is called base, and the same substance when donates its lone pair, donates its electron pair or lone pair to any other, to an atom other than H plus, is called nucleophile. Again repeating, base and the nucleophile are the interrelated terms. A substance when it donates an electron pair to proton is called base, and the same substance when donates electron pair to an atom other than proton is called nucleophile. So base and the nucleophile are interrelated. A strong base is poor nucleophile. A strong base is poor nucleophile. A weak base is better nucleophile. So you should remember this concept: a strong base, poor nucleophile, a weak base is better nucleophile. You should have in the mind. Now, how to estimate or how to understand a base is strong or weak. A base is strong or weak. How to understand a base is strong or weak? To answer this question, I take up the example of water molecule. This can be explained with the help of H2O molecule as. How to understand a base is strong or weak? To answer this question, this can be explained with the help of H2O molecule as. You know that water molecule it dissociates as, or better to say like this, if you like here 2H2O, then you can write here H3O plus OH minus. This gives proton, so this is the acid part, this is acid part, and this is the base part. Now replace the H of the hydroxide group by alkyl group. Now replace H of the OH by an alkyl group as this is hydroxide ion. Hydroxide ion is a base. Replace the hydrogen by or we get alkoxide ion. Alkoxide ion. Now you go on writing different alkyl groups. So you start just from the parent OH. Now add R is CS3. Then R is C2H5. Then R is isopropyl group. This is isopropyl group, and the R is tertiary butyl group. The H of the hydroxide ion has been replaced by methyl group, ethyl group, isopropyl group, and the tertiary butyl group. Now see what happened. This is hydroxide, weak base. This gives impart the plus I effect of this group. Electron pair donation increases, so it is stronger base than the hydroxide ion. In this case, plus I effect is more, still effect more than this one. So this base is more stronger than this one. Similarly, inductive effect is increasing like that. So this is greater in basicity, and likewise this tertiary butyl, this one is more basic, so it is stronger base. So basicity increases. Basicity increases due to increase in plus I effect. So you can write like that. Basic power increasing. Basic power in increasing due to increase in plus I effect. And secondly, the nucleophilic character decreases and it goes in that direction. Now second point is betterment of nucleophile increases. Betterment of nucleophile increases. It means there is inverse relationship between the base and the nucleophile. There is basic power is inversely proportional to nucleophilic character. Thus, tertiary butoxide ion, isopropoxide ion, ethoxide ion, methoxide ion. So thus it shows that hydroxide ion is poor base. Hydroxide ion is weak base. Hydroxide ion is weak base, but it is better nucleophile. So you can say that a weak base is better nucleophile. A weak base is better nucleophile. Remember it from this observation. Second point tells this tertiary butoxide ion is stronger base. Tertiary butoxide ion is strongest base. And what about betterment of the nucleophile? But it is poor nucleophile. So you can generate a formula. A strong base is a poor nucleophile. These are the two observations on the basis of this sequence of the bases. Tertiary butoxide ion is the strongest base, but it is poor nucleophile. So arrow is going in this direction, so it is the strongest one. But for the betterment of the nucleophile, this comes in reverse direction, so it is the poor nucleophile, stronger base. So a strong base is a poor nucleophile. I am giving you some examples. In the form of question. In given pair of bases, select strong base, select strong and poor base, and better and poor nucleophile. This is question. In given pairs of bases, select strong and poor base and better and poor nucleophile. I start with beginners, hydroxide ion or O methoxide ion. This is methoxide ion. This has got plus I effect. So this is poor base or weak base. This is strong base. Weak base is better nucleophile. So it is better nucleophile. And this is strong base, poor nucleophile. So this is first example. Now see the second case. In methoxide or ethoxide, this has got more plus I effect, this has got less plus I effect, so it is weak base, this is strong base, so weak base is better nucleophile, this is poor nucleophile. Another example, this is example 2. Example 3 is, say it is OC2H5. Yeah, I can write like this, O CS2CS3 minus I effect is represented as, and this is CH3COO, this is the acetate ion. This has got plus I effect. This has got minus I effect, and a reverse effect. The electron density is poor. So this is weak base. Weak base means better nucleophile. and this is comparatively strong base. Strong base means poor nucleophile. Poor nucleophile. One more example. Say this is tertiary butoxide ion. This is my plus I effect maximum. So it is strong, or CH3C HO minus, less plus I effect. In this case, more plus I effect. So it is strong base. Strong base. This is comparatively weak base. Strong base is poor nucleophile. Poor nucleophile. This is weak base. This is better nucleophile. Nucleophile. So on the basis of this, I can conclude that a better nucleophile, or you can say that a weak base initiates the nucleophilic substitution. Nucleophilic substitution that is SN2. A weak base initiates the nucleophilic substitution because it is a better nucleophile. It is a better nucleophile. This is very useful for the reactions when I compare the E2 reaction with SN2. E2 versus SN2 when I will take up the class. This observation is very important. A weak base initiates the nucleophilic substitution SN2 because it is a better nucleophile. The weak base, better nucleophile, hence undergoes nucleophilic substitution. Mind it. Next observation is a strong base initiates the elimination reaction E2 because it is a poor nucleophile. It is a poor nucleophile. A strong base initiates the elimination reaction E2 because it is a poor nucleophile. Since it is poor, no question arises. Since it is a poor nucleophile, no question arises for the nucleophilic substitution, but arises for the elimination reaction. So this is point of difference between E2 and SN2 reaction. I will go when I will take a class on the E2 versus SN2 reaction, then this observation will be very useful for you people. Thank you very much.